everyone, and welcome to today's webinar, Developing an All-Encompassing Observability Strategy. I'm Michael Downs. I'm the Chief Technology Officer for Evolving Solutions. And today I'm joined by Chris Farrell. Chris is Vice President of Observability for IBM. But before we get any further along on our webinar for today, which I'm looking very much forward to, I want to give you a little background on who Evolving Solutions is. In case you're not familiar with us, we are a technology solution company. We provide modernization and automation to people's business critical applications. And we're really focused on helping our clients achieve what we refer to as modern operations. So modern operations is really the idea that our clients have come to us with, that they're struggling to be able to transition from a world where they have traditionally done a great job of running a data center, great job of running traditional IT, and now we've got all these cloud capabilities and services. We've moved into this hybrid cloud world where there's a tremendous amount of opportunity for innovation in the technology space that their businesses are taking advantage of. At the end of the day, the businesses look to our clients and IT organizations and ask them to make sure that this IT innovation is available and secure and reliable and running and performs properly and is running the way that they would expect it to run their business. And so in order to be able to do that, there are a lot of tool changes and process and people changes that we're seeing people undertake. One of the key goals is to make sure that you're not doubling your staff or doubling your budget, that you're adopting tools and processes and capabilities that really allow you to get the most out of your organization and provide the value that the business really expects. As you can see, we really have 4 areas in modern operations we focus on. Today, we are really focusing on observability. And Chris is going to share some great insight with us around developing an all-encompassing observability strategy, really focused around an IBM product called Instana. Chris is really the technical director and APM strategist and has over 15 years of experience in application monitoring and management. I love this. He was one of the first the first product management director at Wiley, which was probably launched the APM industry back in 2000. Chris has also led marketing and product management for 5 other APM and systems management ventures, including software currently marketed by Microsoft, CA, Oracle, and VMware. With a BSEE and MBA degrees from Duke and experience in ThinkPad development engineering and manufacturing engineering at IBM, Chris brings a unique perspective that includes a cross-section of both business and technical insights. And I welcome Chris to our webinar today. Looking forward to seeing what he has to share with us.
Thanks, Michael. That was all a whole bunch of very nice things. Those are also different ways to say you're old when you have so much experience in doing stuff.
Absolutely.
But it's exciting to be here, and I'm quite excited to talk about observability. And I actually really have an affinity towards what observability is able to do. And when I joined Instana, which was 5 years ago, we didn't call the product observability. We called it dynamic APM. And we knew that we didn't want to keep calling it APM anything, but we weren't sure what to call it. And it was about 3 years ago where we came upon this idea of, you know what, this really is observability. And so we're going to talk to you today about why observability is important to the world, how it's different from APM, and how it can help you, and ways that you might think about using it and ways that you might not be thinking of using it, but could use it. Why is this important? Why is application monitoring important? And we can talk about digital transformation. And I used to put a little comment on when talking about digital transformation, say it's not your father's digital transformation. Believe it or not, it's not your great grandfather's digital transformation. Digital transformation was first used as a phrase in 1949. Now what we're doing today has very little resemblance to what digital transformation was back then. And in fact, it has very little resemblance to what digital transformation was 20 years ago when APM became a thing. But a lot of the things that we were doing as an industry at the turn of the decade, century, millennium, 2000, um, that IT was trying to do, we're still trying to do, we're just trying to do them better. But the reasons that we're transforming again are different. And we see here a slide. This is from a McKinsey report that says there was more digital transformation during 2020 and 2021 in that, or 19 to 2020, than the previous 10 years. So we did 10 years of digital transformation in 1 year. And we can all point to why we digitally transformed. And it was very important to do more digital things, more online things. Of course, we were all working from home and working digitally and remotely. But there's also a shift in technology and a shift in what organizations are trying to do. So it's not just COVID, it's other things. So what are those other things? Why are we transforming differently and again? And it has to do with speed. The benefits of modern transformation is to be faster, faster to market, faster, more responsive to your customers, to your clients, to your potential customers. Um, and to do that by accelerating your pipelines, by having a faster development team, a faster operations team. And the reason we're doing this is that in today's market, it's no longer the big fish eating small fish; it's the fast fish eating the slow. And believe it or not, one of the interesting things that happens when you accelerate your development pipelines is your development teams have higher morale. So they actually enjoy being pushed to do things quicker and faster. That's something that development teams tend to enjoy. The late owner of the Oakland Raiders, now the Las Vegas Raiders, put it so succinctly 40, 50 years ago: speed kills. Speed kills in sports and speed kills in business. The faster you are, the more successful you're going to be. And how that results in the digital world is modern applications. And there's a nuance to today's modern applications and how they're built in order to drive that speed and that frequency. And that is essentially gathered around the cloud native tech stack. So the first thing that we get from a cloud native tech stack is developers using a specific tool to solve a specific problem. And what I have here are screenshots of about 120 icons of different microservice platforms that are out there. There are dozens of different database types. There are 14 or so different languages that are used by developers now. There's all kinds of messaging systems that are out there. These particular screenshots are from the Instana supported technologies page section of our website. That actually goes on and on and on because Instana actually, we ended up supporting over 300 different microservice platforms. Now compare that to the idea of what do you have to support in APM space? You have to support Java and .NET, maybe one or two other languages, but Java and .NET versus 300. And you start to see where some of the differences in observability comes from, right? Also, you add in hyper virtualization. What do you mean by hyper virtualization, Chris? Glad you asked. Let's think about things like Docker. I like to compare the acceptance in enterprise businesses of Docker to the acceptance of Java. It took about 10 years for Java to be pretty widespread in its use at the top businesses for mission critical applications. Docker was pretty much everywhere in 3 years after it was created, and maybe 5. But the acceptance of Docker was so fast comparatively. And then you add in the level of Kubernetes. So that's the system to manage those containers. And then you add in the concepts of distributions of Kubernetes, which is you take the open source of Kubernetes, you add some security functions, some scalability, some control, and you have your own. Oh, like OpenShift. But also every cloud provider has their own. Amazon, Google, IBM, Microsoft, they all have their own unique Kubernetes instance. By the way, I like OpenShift, not just because it's a Red Hat product, but I like OpenShift because OpenShift allows you to take your Kubernetes and use the exact same Kubernetes across every cloud system because OpenShift runs everywhere, oh, including on-prem. So now you have the ability to manage your hybrid environments and your multi-cloud environments with the same Kubernetes system, but you're going to need some observability for that, because Kubernetes manages the deployment of your Docker containers or other containers, but what it doesn't do is manage performance. So you still have to worry about performance. And oh, by the way, once you start putting these hyper virtualized systems in place and these microservice platforms in place, you start to come up with a new problem, and that is your infrastructure is software. How are you going to manage an infrastructure and software? Very carefully is the answer. And then you add in the concept that microservices and this hyper virtualization creates, and that is a massively dynamic environment and a massively ephemeral environment. So ephemeral, nice little graduate student word, means ever changing, right? So these things become complex, right? How complex? Let's think about a 3-tier environment versus an in-tier environment of microservices. So here's a very simple 3-tier architecture. Now, no matter how complex a 3-tier architecture gets, I can add on multiple data sources, mainframes, IMS on the mainframe, Kix on the mainframe. I can have an Oracle database. I can have a SQL Server database. I can have an LDAP server hanging off the backside, but they're always touching the application code in that app server. So it's always central to one place. So it's easier, not easy, easier to understand and manage. Compare that to a few simple microservice applications we know. And I say that only slightly tongue in cheek, because while all of these applications are hyperscale, they are not exactly complex applications. These are not commerce applications. These are essentially a database of one thing and a set of users on the other side, and understanding how the users access the database, right? These are not highly complex algorithmic applications, but they are highly complex microservices. And a lot of people refer to these as Death Star diagrams, but this is how the world of microservices works. You have many more dependencies, exponentially more, hundreds more, thousands more, and that complexity creates a little bit of pressure on you. So just as a reminder, there's a technology reason that observability is needed. It's all these different pieces of technology: containers, orchestration, Kubernetes. By the way, there's more than just Docker in containers. There's LXC, there's Cryo, there's Rancher, right? And there's more than just Kubernetes doing orchestration. Now, Kubernetes is mostly what we see in orchestration, but there's also the old Mesosphere platform, which is now called D2IQ, and other types of organizational orchestrators that can help. Those are also part of the infrastructure. And so you start to blur the lines here. We talked about cloud native and multi-cloud and hybrid cloud environments. And then we didn't touch on the idea of serverless, which just gives me, still to this day, it's been 7 years since I first heard about Lambda. I got goosebumps then. I get goosebumps today when I think about being able to have a workload that only appears when it's needed and then disappears. But how do you manage that? That's really difficult, right? These are all things that happen and create the necessity for observability. But there's another driver creating observability necessity, and that's process, right? So hopefully everyone recognizes, you might think of this as a DevOps process, you might think of this as a CI/CD process, and whether you think of one or the other, you're right, because it's both. And what's happening is organizations, remember, we're trying to get faster, are trying to speed this up, right? If you think of it from CI/CD, you're thinking as a pipeline. If you're thinking of it as a DevOps process, you're thinking of it as a release process. And again, you're right both times. And speeding this up is an interesting exercise, because if you start at plan and you go all the way around the little infinity circle, there are many different ways that you can automate the parts of the pipeline here. Lots of different tools during coding, building, testing, releasing, even deployment, and especially operation. Lots of automation tools. Michael mentioned that they're in the automation business, because there's all kinds of places that you can automate and should automate. And in the CI/CD world, as you get more agile, there's all kinds of places to automate. But automating monitoring, not a lot of automatic monitoring tools. And I like how an analyst once put it to me about 4 years ago. Said, well, everyone knows you should automate monitoring, Yes. Everyone knows you should automate monitoring, but there's not a lot of automated monitoring out there. And so what happens is, as you accelerate all the rest of this pipeline, you hit a roadblock when you get to monitoring. And now you have to make a decision. Do you go live to keep the speed up, your acceleration, your velocity? Do you go live without full monitoring available? Or do you wait, reconfigure, reset the monitoring, get it manually set up, and then go live? So you can either slow everything down, and hopefully, maybe if you slow down, you don't slow down too much, but you slow it down, or you go live blind. That's not, neither one is a good option. Neither one, both can have lasting impacts. I think the worst decision is to go live without monitoring done, because you're going out there with gaps. And when you have gaps, Murphy's Law says that any problem that happens in your application environment is going to be on those gaps, right? The first time that someone talked about APM with the idea of you can't fix what you can't see, I think it was about 13, 14 years ago, probably even longer than that. But I just remember when Forrester wrote a blog post about you can't fix what you can't see. They were talking about moving from just plain Java to more distributed environments. But now we're talking about a massively distributed environment, a massively complex environment. And of course, you add in this blurred line of infrastructure and software. Um, so what does that look like in the real world when as you're dealing with these problems? So let's talk about the war room. Let's think about a world before APM existed, or maybe a world if you don't have APM today, if you're running without it, which it can happen. And then in this world, you play the blame game, right? It's the network's fault. It's the server's fault. It's the coder's fault. It's the database fault. It's the DBAs. Everyone's pointing fingers at each other because everyone has their own tool for their system and it's green, but the users are calling complaining, right? So nobody knew how to fix things. And then along came APM and things got better. First of all, APM was a way to kind of figure out who wins the blame game, right? And it's not a single winner. It was everyone except the person who all the fingers should be pointed at anyway. But what APM really did was it changed the war room to be collaborative. And it didn't take a very long time for this to happen, a few years, but I would say that within 6 or 7 years, all war rooms became collaborative. And now, instead of getting together and pointing fingers at each other, everyone still got together, but now they had APM as a common ground of something that showed how everything was working together. Well, not everything, but everything from the application perspective. And so everyone could kind of get together, look at the data, have the meeting be driven by that APM power user and say, this is the data we're seeing. Developers, what is this doing? DBAs, how does this work? Architects, is this how everything's supposed to be? Where is this showing that it's going? This big spike here. Where does it go next? How can we get there? The reason everyone was there was because you're working together to interpret the data to understand what's going on. So, in other words, you're collaborating to get understanding, right? And that it was a lot better than a blame game, a lot more collegial, a lot friendlier. It still wasn't great because you still had to get together in a war room. And maybe for some problems, that war room lasted a long time. Hopefully not days, but sometimes days. I've seen customers that had war rooms that lasted for weeks. Those are not happy war rooms, even though they are collaborating. And I'm going to tell you that one of the things that observability is going to get you to do is to stop collaborating. Wait, Chris, that doesn't sound good. Going backwards, finger pointing game again? Nope, nope. What the cool thing about observability is that observability gives everybody the data they need when they need it about the systems that they care about. So that instead of getting together to understand what's going on, the platform delivers the understanding, right? So now I want you to think about this room, and I've done the counting. There's 12 people in the room, right? Only one person is responsible for the problem that they're trying to solve. So that means 92% of the people in this room are wasting their time. They're in there to work together to figure out that it's Jim's problem, right? Uh, but what if the tool could just say, oh, we have a problem and it's Jim's problem? Everyone can just look at their day and go, yep, not my problem. It's all good, right? 1 second, I'm done. I don't have to go to a war room meeting. By the way, this is a 12-person war room. What's your war room? I know customers that have had that regularly start with 80, right? Oh, we have a sub one problem, call it 10 a.m., 80 people on the call, right? How long is it 80? Is it an hour with 80 and then another hour with 40 and then another hour with 20, right? The point is that everyone whose problem it's not is wasting their time on that call, right? Of course, if that's your process, you don't think of it as wasted time, but that's where you start getting time back. Now, how does this work? How do you get something that used to be called the same thing that we're going to replace, but now it's that much better? It is. But we're going to talk about what makes it better. And a lot of people think about observability as just taking metrics, traces, and logs and throwing them together in a certain way. And there's a lot of that is part of observability. But I'm going to talk about how you do that through automation to get an understanding of context so that you and your tool can take intelligent action. And that's the biggest difference because this all comes together. And actually, the most important and the most dangerous word on this page is the one in the dead center, context, right? Because, pun intended here, without context, context has no meaning. That sounds really funny, Chris. Yes. So why do I like to get excited about this? Because um, Instana, which was acquired by IBM 2 years ago now, coming up on 2 years, delivers something that we call enterprise observability. And that means that we have metrics, traces, and logs, just like you'd expect. But it's how we do these things that's important. We automate the full monitoring lifecycle. Think about what that means to your operations team, to your developers, to your architects. We installation, automated, discovery of what's running, deployment of the appropriate monitoring sensors, configuring those sensors. We do this with a single agent. That's a whole different world too, but that's way down in the weeds of single agent versus multi agents, right? We automate the idea of what you monitor. We curate that. We automate the idea of setting up alerts. You don't have to set thresholds. By the way, if you have thresholds you need to set, you can, but you don't have to. We're going to put anomaly detection in there to tell you when things are going awry, and we're going to automate troubleshooting. What? Troubleshooting? How? We're going to show you the actual event that caused your service incident. We're able to do this because we're tying everything together. That sounds like context. We'll get to that in a second. We even can automate remediation depending on what you're doing. So everything that you have to do in monitoring, you no longer have to manually deal with. Now that's great when you start using a tool, right? You put us in, 5 minutes later, you got a map of your infrastructure, you got a map of all your applications. That's fantastic. It's really cool. That's not the value. All that really is more valuable as changes occur. And let's remember all the way back to why are we digitally transforming now? To speed things up. In this world, changes should occur all the time. The more frequently you're changing your software, the more frequently you're updating your software, deploying new pieces of it, the better off your performance is going to be, the better off your organization is, the better off your customers are going to be. But that means you have to do all of this if it's not automated every time you make a change. So the fact that it's all automated brings the value the faster you deploy your software, the faster your pipeline is, right? Context. What does that mean? It means understanding how every single piece is related to everything else, right? So your infrastructure pieces to your application services, each service talking to each other. How are they related to the end users? Being able to do a trace from an end user, whether they're on the website or on a mobile device. Oh, and if it's on a mobile device, let's manage the mobile app, right? That's part of it too. And bring it all the way through your systems to the back end and inside, right? So one of the cool things about being bought by IBM is that we deployed the first ever native application monitoring agents inside Z. So all those other tools that have been out there for 20 years, starting with Wiley, the first one, was able to see ways that you were tying to databases, right? The Kix gateways, IMS connector, the MQ series connector. Those were fantastic things that Wiley could do. The APM tools now have this thing that IBM created called the APM Connect that gets information out of the mainframe that helps them understand. But we actually put our agent inside the mainframe so that now you understand exactly how it's working. So it's this context of understanding how everything ties to everything else that gives both our tool, which has AI and ML built into it. You can't analyze things if you don't have the right data, and a rich data helps us, but it also helps you because now you know how everything relates to everything else. And that means that the tool can take intelligent action immediately and automatic in some ways, right? But it also allows your teams to be more intelligent in the actions that they take. So that's how we combine these things together. The what is it, metrics, traces, and logs, and how do we do it? We automate context so that you can take intelligent actions. And what do we mean by everything? Think about it. I mentioned it all. Everything. Oh, another, by the way, you like profilers? Your developers do. We actually have production profiling that's always on, right? So one of the cool things about over the years is every new tool got overhead a little bit better, a little bit better, a little bit better. So so that now you have the opportunity to actually deliver profiling for your developers from your production systems, and it's always on, so you never have to worry about missing a problem. You'll always have the data you need. So that's what we do with Instana. And here's a final like summary slide bringing it in. I actually haven't even been paying attention to time. I think we're on time, but the great thing about this tool is that it works within the environment that you've set up. If you have straight DevOps, we work in that. If you're not DevOps yet, it works for that environment too, because it's designed to give any user the data they need. That's one of the differences of observability versus APM is who uses it. APM is usually used by a set of power users that go to lots of training and have to know lots of things about the systems that they're managing. Observability is used by hundreds of users at environments, many of them developers, architects, application owners, etc. And so this is what makes observability different from APM, is that it delivers that understanding to everybody. One last piece. What does this mean in the real world? Take your pick. I'm not going to walk through all of these. My favorite is freeing up developer time, right? You can talk about reducing time to solve problems, but freeing up developer time is one of the biggest values you can give any organization. We have 30% here listed. I know some organizations that actually freed up half of their developers' time. What does that mean? That means they can do twice as much now that their developers are no longer always on the hook to help configure monitoring and to help that war room figure out where the problem should be.
Awesome, Chris. Thank you. I think you hit another important point for observability from on operations from our perspective, which is that it's got to be developer friendly, and if it's not, you're not doing your job, right? Because we've talked for years about how we've got shadow IT and what are we going to do to stop shadow IT and everything else. It's my basic philosophy. If you don't have shadow IT, you're probably doing something wrong. Because that's where a lot of the innovation happens. And it's our job as an IT organization to provide them the stuff they need to not be in the shadows anymore, and be able to get their job done. And so Instana and observability, I think, plays right into the middle of that. And you're freeing up developer time is a huge component of that. So
I like the idea of the shadow IT, Michael, too. When you give everybody the data that they need, it's so empowering for everyone.
Absolutely. Well, thank you, Chris. I really appreciate it. Very good presentation today. I love the Instana perspective, and I appreciate you walking us through sort of the evolution of getting here. So thanks for joining us.
Thanks for having me.
You bet.